Today I'm going to continue working on acid-base chapter, and the topic for today will be buffer solutions. That will be our topic for today's class. What is a buffer solutions? Buffer solutions are solutions that try to keep the pH constant under certain condition. It doesn't mean that they will keep the pH forever, but the solution will try to keep, if you are an acid or a base to the solution, they will try to keep the pH under certain limits. For instance, how can we prepare a buffer solution using a weak acid? A buffer solution is a combination of the following. It's a weak acid mixed together with the conjugate base, and it can also be actually weak acid, or it can be a weak base mixed together with the conjugate acid. Let me give you one example of the first one, and then we will go over the second one. Let's erase all this, and for instance, acid plus conjugate base. A weak acid, of course, has to be a weak acid, and we can prepare acetic acid, a solution of acetic acid. Acetic acid in solution will act as an acid based on Brontes-Lowry definition, because it will give a proton to the water. So this is an acid, and this is a base because it's accepting a proton from the acetic acid. So this one will produce the ion acetate and the hydronium ion, this one here. Notice the following: the acid will have an ion. This ion is the conjugate base of the acid, and this ion is the conjugate acid of water. So the weak acid will produce a conjugate base, and the base will produce a conjugate acid. So how can we prepare a buffer solution using that kind of combination? Well, we can mix together, let's say, 0.2 molar of acetic acid. Forgot this CO2 because this is the formula of acetic acid. 0.2 molar of acetic acid with, let's say, 0.1 molar of ion acetate. So you get a beaker with that solution, acetic acid, and you add the ion, let's say, by adding sodium acetate solution that contain a common ion acetate, and that way you prepare the buffer solution. That buffer solution, when you add an excess of acid or an excess of base, it will keep the pH constant under certain limits. That will be a buffer solution with a weak acid at the conjugate base. Let's see another example. Let's try to make a conjugate, a base, a weak base with the conjugate acid. Ammonia is a weak base in equilibrium equilibrium with, reacting with water will form the following equilibrium. It will acting as a base, accepting a hydrogen, a proton from water acting as a base, and water will be acting as an acid. And that will form the ammonium ion, which is this one here, and the hydroxyl ion. So this is a base, and that will produce a conjugate acid. And that will be the combination that you will have a buffer solution. Water is acting as an acid, and the ion produced by the water will be the conjugate base. So if I want to prepare a buffer solution, I will get a beaker, add, let's say, 0.3 molar of this base solution, and then adding any salt like ammonium chloride, let's say 0.1 molar, and that will prepare my buffer solution that will keep the pH constant among certain limit. That's the definition of buffer solution. Thank you for watching, and this is it for today.